All right, everybody. Did you get your caffeine? Do you need more? What did? The coffee was gone? I'll get that fixed. I apologize. I'll get that. Both stations of coffee was gone? Who drank it all? Well, we'll find out. Okay, I gotta just tell you, I'm excited about this. I was at a conference this past summer called Take on the World, and it was awesome because I got a chance to. Well, first of all, I was there speaking, and there was a lady that when I was giving my speech, there was a lady that I kept. It's like, when you're doing a speech, you kind of catch eye contact, but I'd look out and I'd see this lady going, "Yep." It's just had this just demeanor, this awesome demeanor. And I had no idea, who this lady was. And then I look over and I see this guy, that familiar face, obviously. I'm like, "Hey, what's up, man?" And as I continued on with my my little speech and I got done, Paul on the Plane walks up with his mom. So I got to meet Paul on the Plane's mom this summer, and it was just, I can see where he gets his demeanor and kindness and the way that he lays things out. And that's the thing. So our next speaker, I'm just proud to bring him on the stage, and he had a great session at Take on the World. And what I saw, there's one thing to listen to somebody. It's another thing to actually watch them in person and have that connection and the touchability and the relatability. So without further ado, I'd love to bring on a very special guy to this whole movement, whatever you want to call this. So please welcome from Paul on the Plane, Paul on the Plane. Is your mom watching? Is she here?
No, she's not here.
Oh, you did. I was like, what? She's here? Oh, I was like,
that would have been a special surprise.
I got to say hi to Cassie. Hi, Cassie.
Hi, Mom.
Hi, Mom.
Hi, Mom.
I just wanted to tell you hi. She's a wonderful lady, so thanks, man. Thanks for being here.
Thanks for bringing that up.
Yeah. Nope, your mic's there.
Here we go. Can you hear me?
How it going, buddy?
Well, let me get my presentations opened up here. And my clicker. All right. I'm tickled to be here. I can't believe I'm on the stage here in Dallas on the main stage. Really just a privilege and an honor. I don't take it lightly at all. This is really an honor. But there's some kind of sick joke. How did I have to follow Rob Skiba? It's a conspiracy, I swear. At some level. All right, faking space. That's what I was asked to present on. And, my story is probably not unlike many of you. And that is when you first heard about this subject, conversation going on about the shape of the world, the first thing I thought of was, we've got pictures from space. How can anybody in their right mind begin to even think that the Earth is anything but a sphere? Right? So that's what I did, obviously, as I started looking into that. And what I'm going to be presenting here this morning is kind of what I found. They're highlights from my video series that I started putting online in the summer of 2017 called Faking Space. And I had a lot of help, and I want to, before we get too deep into this, I want to give a big shout out to my former partner in the series, and that's Archer Sage, who had a lot to do with this series, and we spent a lot of time together, and he showed me a lot of things that he had found and was really the catalyst. And we spent many hours together looking online and reviewing the FTP sites and folders from the space agencies, and he'd message me and say, "Oh, look what I found today," and we'd jump on a Skype call and go through it, and yeah, should we put this in one? Yeah, so that's what was going on. So a big shout out to Archer for sure, and of course shout out to my mom. Hopefully she's watching. She wishes she could be here, and of course shout out to Ace McLeod. So my story starts with my wife came home one evening in late 2016. It was October, I believe, and she said, you know, there's people out there that think the earth is flat. And we had a little bit of a laugh about it. You know, I scoffed at it, obviously. And we went about our evening, had dinner, what have you, and we didn't really talk about it again that day. But there was a seed planted in my mind, okay? And I didn't just dismiss it for whatever reason. I decided that wanted to understand why people would even think that. I was curious, just flat out curious. Literally flat out curious, I guess. So I did what everybody did, and that is, make sure my clicker works here. I Googled Earth from space, and you guys probably all did the same thing. This is what you come up with. And I started looking into this stuff, and I started to realize that, are these really photographs? You know, that's what I had to overcome to really begin this journey. And so again, highlights from my Faking Space video series is what I'm going to be going through here. And they're all available on my website, on my YouTube channel, as long as they'll remain. I hear that they might all be taken down here soon, but everything lives on paulandtheplane.com. So if you haven't seen the series, and you know, there's little short videos, 8, 10, 15 minutes each or something like that, and you can kind of go through and see in detail how I came up with some of this stuff. All right, so that was my stumbling block, Earth from space. So let me show you what I found. And this is the animation from the video series. Big shout out to Andrew Lankus. You've heard his name a couple times this week. He's one that put this together for me. And right now about 2.5 seasons worth of videos, and I've been doing a lot of the moon landing stuff, but what you're going to mainly be seeing here is the first season and a half of that series. Oh, and the cool thing is, a lot of you guys are probably aware what's going on in Brazil right now, and we get an understanding of what, you know, how this thing is blowing up in South America, and specifically as Brazil. A big shout out as well to Rodrigo Ferrari Nunez, a good friend of mine, PhD anthropologist, but he is translating this series into Portuguese so that that can be shown down there as well. So I think, not that they doesn't sound like they need it, but they're doing a great job. All right, so when I began the search for Earth from space, you guys probably came across this too, and that is the first picture that we allegedly have from space is from October 24th, 1946. It's a black and white image, 65 miles, from a 35 millimeter motion picture camera aboard a V-2 rocket above White Sands, New Mexico. And the first thing I thought of when I saw this picture or image or photograph, whatever you want to call it at this point, is there's no curvature. First picture we had from space. Interesting. But inevitably, as Rob Skiba brought up in his presentation, this is what you're going to come across as the best proof, and this is the 1972 blue marble from the Apollo 17 mission. And did you know that all 3 astronauts aboard that mission claimed to have taken this iconic photo? At one time or another, they all had claimed to have taken it. Of course you would, right? I mean, this thing was for 43 years, which was the image of the Earth. But we're all used to this. But if you dig in and start understanding more about this, I call it a painting, here's what you're going to find. That's actually the original. It looks a lot blurrier to me than what they provided. So my theory is, I mean, again, this is the 1970s. This is the original image. If you go to the website here, and I got the URL in there, this is the original image, and it's much blurrier than obviously what we were shown. In fact, there's 3 versions of it. This is the, again, claimed to be the original. But in the 1970s, I mean, I don't know, I wasn't taking pictures then and trying to improve them, you know, in the dark room or whatever they were doing then, you know, really before digital photography was taking off. But, you know, how did they turn, you know, that original image into something so clear without digital enhancing it? So that's why my theory is that they probably, you know, took, this is the second image we got, they cleaned it up, and then they flip it over and they further enhanced it. So that's kind of the stages that it went through. But I just find it really interesting that they went from that to that in the 1970s, when this is the original. How did they do that? Well, my theory is that this is a painting and they took a picture of it, and then, well, you had to kind of make it look like the rest of the Apollo mission photos. that we were shown. And so I think they just made it a little bit off color and made it blurry, and they said, well, that was the original, and then we enhanced it for you. Just my theory, but that's kind of what I found when I started looking into it. So then you come across Blue Marble 2.0, all right? You guys know this story. You guys have heard of Robert Simon, right? The NASA data visualizer, right? I believe that's his title. And he even said that this is not a photograph. It's built in Photoshop by a digital painter. And in fact, he called it a sophisticated visualization. And certainly a callback, obviously, to the 1972 original Blue Marble that I believe is a painting. And this obviously would be considered a digital painting. And there he is, Mr. Blue Marble 2.0. And what was really interesting, I thought, was as I was investigating this guy and just learning more about him, this is what's on the NASA website, is that he was going through, this is kind of like a little bio or something like that, and talking obviously about his creation, this Blue Marble. And it goes through and he says, kind of how they made that. And then he said the hard part was creating a flat map of the Earth's surface with 4 months of satellite data. And he mentions this guy or lady, Rito Stockley, now at the Swiss Federal blah, 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 did much of this work. And then he says, then we wrapped the flat map around a ball. Fair enough. So, they obviously, as many of us have already learned, they admit that Blue Marble 2.0 isn't a photograph of the Earth, it's a digital composite. I also found it interesting in learning more about Robert Simon was an article, and this was from, and I don't remember the exact date, it was shortly thereafter the Blue Marble was created. But the title of the article was, "The Guy Who Created iPhone's Earth Image Explains Why He Needs to Fake It." And it goes through and quotes him, and at this point of this article it says, it's simply a background of black color that Simon placed the Earth on top of. The black area around the Earth is not the void of space. It is simply a background of black color that Simon placed the Earth on top of. This is standard practice, Simon says. Most actual, quote-unquote, photographs of the Earth, including the Apollo images, present the planet on a black background. So my question was, what is the scientific value if all of these things are admittedly manipulated? Why would they take a picture of something and not just show us the picture? Why do they have to cut out the Earth and put it on a black background? I mean, I don't know. Maybe that's just me, but I just find that really odd. Why don't we just see the picture you snapped? Why do we have to have all this post-processing or manipulation? Well, that was obviously a long time ago, 1972, the Blue Marble. But, at this point in my journey, I'm like, look, but now we're getting pictures of the Earth daily. In fact, we've got satellites up there, I'm told, that are giving us pictures of the Earth every 10 minutes at some point. And that's the Himawari. So there was 3 main satellites that I learned about that are giving us regular images of the Earth daily at this point in time in my journey. And that's the Discover satellite. That's the one on the left there. And the one on the right is the Electro-L, which is a Russian satellite. And then the one on the bottom is the Himawari 8. These are the main that I came across. Now the Discover is, and I'll talk about that one in detail. We're going to look at some images from the Discover satellite that we got. In fact, it's not even producing images anymore. It's actually offline, so unfortunately, and they haven't been able to get it back online since June of this year. But beside the point, that one is a lot further away. The Discover is like 1 million miles away, and the other 2 are much closer. They're only 22,000 miles away. This is obviously according to NASA and the franchise space agencies that they are working with. So what I began to do, and this is again what Archer and I started working on, was taking the images from these satellites of the Earth and performing kind of a forensic analysis, if you will, an investigation, almost like if you were in some sort of a court battle or a court case, and you were trying to prove that or disprove that an image was authentic or not. We would be putting these images into software programs and looking at how they would react to the forensic tools. And we would be comparing those with real, actual photographs that we knew were real, that we had taken ourselves. And that's essentially how we performed this analysis. So we learned how our photographs that we took would react to these tools, and then we would say, okay, now we understand what a real photo does in forensic software or any sort of a forensic analysis. And then we'll drop in some of these space agency images that we get of the Earth, and we'll do the same thing and just kind of compare results. And so this is what we found. And mainly we used Photoscape, that's just very simply a photo editor, just like Paint, and it's basically a free version of Photoshop. Doesn't obviously have all of those capabilities, but it's free. And we wanted to use tools that were free, that you could just download. Anybody could just download and use. There weren't any licenses you had to buy, so anybody could do the same thing that we were doing. And we would provide the links. Here's where we got the photo. Here the image. Here's where we got the software. Hey, do the same thing. See if you come up with something the same. See if you come up with something different. We used JPEG Snoop, which will tell you if a JPEG basically is it raw and unmanipulated, or has it been processed? Has there been what signature exists, and what photo editing software was used, and things like that. And then forensically was probably the most powerful tool, and this is a web-based, not even anything you download. It's a web-based forensic tool where you just point your web browser to the site, and you drop the photo in, and you start using all these different functions, which is really, really cool. So this is how we began. That is not my son. That is just a picture of him. It's a picture that I took with my Nikon P900. But he's a handsome guy, isn't he? He's mine. He's involved in theater in school. He's in drama and that sort of thing. That's his passion, and he's really good at it. And I love you. Hopefully he'll see this soon. But I thought this was a great image to use to begin this analysis, because here is my son on stage in a very dark room, and he's just got a spotlight on him. Bam. Okay? One light source hitting him right in the face. And so this is kind of where we started. So that's the original image, and there was kind of two main things that we were looking for that all photographs have. Okay? No matter what kind of camera, what have you, whatever you're shooting at, there's going to be two main components that are always in a photograph, and that is noise. Any photographers in the house? Not really? A little bit? Is noise an issue? Yeah, it's a big thing. And it's always there, okay? So, you can obviously, there's techniques to reduce it, that sort of thing, but it's always going to be there at some level. And what we were looking at was kind of a consistent noise pattern in the photograph. And you can see, and that's what all those little white dots are. It's very consistent across the photograph. And that's the digital camera trying to resolve all of those, dark areas and the electrical signals and that sort of thing. So obviously the poorer the quality of the image, the more noise there's going to be, and et cetera. But you're going to see noise, especially if you compare it to the original. There's a lot of dark areas, and you see nothing but noise in those dark areas. The second thing that we looked at was ambient light, and that is light that is present, basically, in the photograph. The light in this case was a spotlight that was hitting my son directly in the face, and hitting obviously the stuff that he's holding, like a newspaper, and he's sitting on a couch or what have you. So the light then hits that and starts bouncing off of it and bouncing all these different directions. We can kind of see that obviously that the light is hitting him and bouncing off. And that's essentially what we're looking for, because again, whether you're shooting inside or outside, you're going to have ambient light, whether it's just sunlight or daylight or artificial light. Light is bouncing off of the object that you're shooting and then goes into the camera lens or your eye, and that's ambient light. So we're going to look for presence of obviously ambient light to be a real photograph. All right, so once we started to understand those things, we took our camera, or I took my Nikon P900 outside, and I started shooting the moon. This is a perfect object to be able to understand what a real photograph would look like of allegedly a sphere in space, right? So this is the original, and then we did the same analysis. There's the noise analysis. This is a picture that I took with my camera. I know it's authentic. I know it's real, and in fact, I got a lot of great pictures that day of the moon. This was in April 2017. That's the noise profile. Again, very consistent across the whole photograph, and there's ambient light. And this one is really interesting because, unlike my image of the photograph of my son, where there was a lot of uneven edges, so as the light came in, it was bouncing all over the place. In this case, we've got ambient light, and whether you believe that the moon is producing its own light or it's reflected sunlight, either way, we've got light that is emanating from that object, whether it's bouncing off of it or it's producing it itself, and that's very evident in the ambient light profile there, and you can see how, I believe there's a laser pointer on here. Guess not. You can see how the ambient light is more prevalent right next to the edge of the moon and then kind of slowly dissipates away. Okay, so it's a really, I think, good example of how we would expect photographs of the Earth or any celestial object that we would take pictures of that's producing light, whether, again, reflected or producing its own light, how it would look in this forensic software, this ambient light profile. So those are kind of some of the things that we did, and kind of the baseline for our investigation was understanding how a real photograph works, would appear in these sort of forensic tools or software. So again, just real quickly, original, there's a noise profile, because we were basically going to compare all this stuff to what we saw with the moon, because that's, we would say, the closest thing that we could do to emulate a picture of the Earth from space would be taking a picture of the moon at night, and then ambient light. So that's what we're going to look for. And again, I got a lot of great pictures of the moon that night, so I just threw that in there because, yeah, this was my actual photograph, unmanipulated, raw image. Not a raw format, it was shot in JPEG, but unmanipulated, unprocessed image that I pulled right off the camera and dropped into the software to see what it looked like. So I got a lot of great photographs, and then the other piece of the investigation is understanding the metadata. So when you take a picture with your digital camera, it's going to capture a whole bunch of information for you. In case you guys weren't aware, you're going to have things like the image sensor, which is ISO, and you can see what my settings were for the camera when I shot the moon. This was based on just going online and saying, what are the best settings to shoot at the moon, or the recommended, so that's what I set the camera to. The ISO was 100, the shutter speed was 16.6 milliseconds, so that was 1/60th of a second. F-stop was 8. That's the focal length, or divided by the aperture diameter, if you get real technical in understanding the camera settings. So these were the recommended settings, and all this information, you got the day, the time. In fact, if you even turn on your GPS, whatever, on your camera or your phone, it's going to tell you where the picture was taken. You're going to capture all that data. That's all called metadata. All right. So at that point, I started looking at what are the most iconic pictures of the Earth from space. And that's what I went around and looked at all the websites and started downloading all the photos. And people may argue, okay, well, these weren't the original unprocessed images. These are obviously on websites and things like that. Well, that's true. But here, to show you what I found. Here's the original. This was from the Voyager 1, 1977. So this is the Earth and the Moon. It might be kind of hard to see. But when you do a noise profile, this is what I started seeing prevalent throughout my investigation, was that there was no noise in space. It was just the objects that were emanating any sort of noise or showing any sort of noise. And ambient light, same thing. I would expect to see light emanating from the Earth, from the moon, just like my picture that I took, but that wasn't the case. And I'm going to run through these pretty quickly because I know we're trying to make up some time with this presentation. So this was a NASA asteroid rendezvous craft in 1988. There's the noise profile. Again, you're going to see a lot of consistency here, ambient light. Again, the dark areas of the quote-unquote photograph taken from space, not showing any noise or ambient light. This is a photo from allegedly from the European Space Agency, 8 million kilometers away, and it was 2003, heading to Mars. There's the original. There's the noise profile, or lack thereof, and ambient light. Again, the same thing. You're seeing a pattern here. This is the NASA orbiter heading to Mars in 2007. No noise, no ambient light. And it gets a little interesting when you introduce another object, like the Cassini Earth from Saturn image we got in 2013. This was called The Day the Earth Smiled. Allegedly, that is the Earth there. I don't know if you can see it on the screen, but it's just below the Saturn rings and a little bit off-center right in the picture. But when we do a noise analysis, it gets really interesting. It's all over the place. Again, no consistency there, but that's what the noise analysis showed. And ambient light was really interesting. It was I don't even know how to explain that. But this is what we found from that image. And then another one from the Cassini in 2017. This is Earth between the rings of Saturn. There's the noise profile. and ambient light. I think we have one more. Chinese orbiter 2014. This is from the dark side of the moon. We got a picture from the Chinese orbiter. Noise, again, just over the objects floating in space here, and no ambient light emanating from either one. Mars Reconnaissance Orbiter 2016. Again, the same thing. All right. Well, that ambient light profile is very weird. But anyway, you get the point. Oh, this is the pale blue dot, 3.7 billion miles away. I just threw this in because I think if anybody thinks, I don't know, maybe I lack critical thinking skills, but if we are taking a picture of the Earth from 3.7 billion miles away, I got nothing. All right, but after 43 long years, after the original blue marble, this is the only image we had of the Earth, we were told, for 43 years. NASA launches the Discover satellite. That stands for the Deep Space Climate Observatory. And it has this epic camera. And it is so epic. Wait till I tell you about this epic camera. And EPIC stands for the Earth Polychromatic Imaging Camera. And it was launched on July 4th. It was launched in February 2015. And eventually, July 4th, 2015, it settled into this perfect spot between the Earth's gravity and the sun's gravity so that it could maintain a position so that it was always facing the sunlit side of Earth, 1 million miles away, this perfect spot between the two gravitational poles of the Earth and the sun. Somebody forgot to tell the NASA visualizer how the heliocentric model works, because look where the sunlight is hitting the Earth and look at where the shadow is. I just thought that was interesting. So the EPIC camera in July of 2015 sent us 2 images, and these are the 2 images. Now, I mentioned the EPIC camera. Does anybody in here still have an iPhone 6? Oh, I see a couple. The iPhone 6, I believe, has an 8 megapixel camera, all right? The EPIC camera has a 4 megapixel camera. It's half as powerful as your iPhone 6. When did the iPhone 6 come out? What was that? Same year, 2015. So the same year that NASA launches this EPIC camera, it has half the power of or half the resolution of the iPhone? I just found that very interesting. The iPhone 4 had a 5 megapixel camera in 2010. Even better than this EPIC camera. So these are the first 2 images that we got, and everybody was, going crazy because we finally, after 43 years, had a full disk image. This is supposed to be a photograph of the Earth from space. Let's see here. So naturally, the first thing I had to do was do this quick analysis. I want to look at the noise and ambient light, and you guys can probably guess what's going to happen here. There's the noise profile. No noise in space. Ambient light. Nothing emanating from the edges of the Earth. I wasn't really surprised at this point. They made a big deal of it in Popular Science magazine. This is what the Earth looks like from 1 million miles away. I mean, wow, that's amazing. And this is the July 6, 2015 image of the Earth from space from this EPIC, not so EPIC camera. And the reason I think they used this was 2 days later. So July 4th is we got the first 2, and then this is July 6th. So 2 days later, this is the image that many of you have probably seen, because there's something that appears to be written in the clouds. But you have to flip it over to see it. Many of you maybe have seen that, but that was where that came from. It's the EPIC, not so EPIC camera in July of 2015. All right, now we're going to switch to some animations that we got. I say animations from NASA. This is from July 16, 2015. So they couldn't wait to get something out there, because this is only, 10 days later. Once we started receiving images, 10 or 12 days later when we started receiving images from this EPIC camera, this Discover satellite, there was a transit of the moon in front of the Earth. And so I believe it was 12 or 14 images that they stitched together and provided this animation. And you guys probably remember this, remember coming across this. This was, again, in 2015. What I found most interesting when I looked at this is this was allegedly these photos of the Earth were taken over a 4-hour period and then stitched together to make this animation. Well, how come the clouds aren't moving? Because they don't move. I mean, if I stick my camera pointed at the sky pretty much any day of the week and just let a time lapse go for 4 hours, unless it's a bluebird day, I'm going to see some sort of cloud movement. But that's the first thing I noticed. And here's the other thing that I noticed in looking through the website is that they have 2 different sections. They have and this is where you pull these, allegedly these images right off of the server there. I have some glitches. This is the date section, so you can go into any of the dates and anything in yellow. You can see where the images are that you can download. So that means we got images from the satellite that day. And what was interesting when you go to the date section, again, this transit allegedly was from July 16, 2015, but you can't find any of those in the date section. The other section is the gallery section, and when it comes back, hopefully be able to see it. Guys? Should we try turning it off and on again? Hello, YT. That's what I did. Is it a loose connection? Where were we? Sorry, guys. Give me a minute. It doesn't like that. Oh, here we go. Okay, we're starting here. So I took those transit images and I downloaded the first 7 because those are the ones with the moon in it that you can see, and I found something very, very interesting when I started messing with the levels. Okay, this is when we started messing with levels as far as dropping, these images into Photoscape or Paint or obviously Photoshop or anything like that, and you start increasing the brightness, and here's what we found in those same 7. You guys see it? It's 2 moons. I think it's a moon. I don't know what else. It's a ghost moon. This is the same animation then. I just brightened it way up so you can see it on the right there. It's about the same size and shape, moving at the same speed, different color. I don't know what caused it. I think it's a software glitch. I think when they rendered this thing, and the reason I think it's not a second object, and I think it, is kind of a mirrored image of the moon, is because, a lot of the features are the same. Same size, same shape, and that sort of thing. So I think NASA just messed up here. I think they just very simply messed up. Some people say, well, there is a second moon up there, and I say, well, I think this is a software glitch, because it looks like it's the same object, but when they rendered it, there was an issue. But don't worry, NASA ends up fixing it, because a year later, in July 2016, we get another lunar transit, and this time they didn't let that happen again. I was looking for that second moon a lot, but it wasn't there. So they fixed the glitch, and again, 4-hour time lapse, and clouds aren't moving and that sort of thing, the same sort of thing. Well, this was interesting is I downloaded 2 of the images randomly from that transit and dropped them into forensically and Photoscape, et cetera, and started messing with the levels. And in these images, we have a box around the Earth now. And they tilted the box, too. So some people would say, well, that's just one image, and you know, that's why you see it like that, and then they just tilt it. And I was like, well, why are they tilting stuff? Why do they have to do that? This is an image. You know, what's the scientific value if they're going to be messing with this stuff? Yeah, it's like 23.4 degrees, right? 66.6. Let's see here. So that was really interesting, obviously. So I said, well, I wonder if the images the day before and the day after, immediately, you know, the last image on the day before this lunar transit, because they were all like that same day, there was 15 images, they all had the same box around it. The day before and the day after, if I take the last image the day before and the first image the day after and do the same analysis, let's see what happens. I should see the same thing, probably. Well, no, I don't. There's no box around the Earth. It was only on that day. That's how they fixed the glitch. We found the next error. I swear NASA just throws the stuff out there and then we all find what's wrong with it and then they learn how to fix it, right? We're doing all the hard work. And again, when you do the noise analysis and that sort of thing, no noise except for around the object and looking for the box and that sort of thing. So the only time that we saw these anomalies is when the moon was introduced into these images, whether it was a rendering glitch and they, you know, had 2 moons, or they included this box. All of the other images on all the other days, just normal days with no moon, looked like this, just like the other images that we get from the Earth from space. No noise and no ambient light. I'm going to switch over to March 2016 now. This was a solar eclipse, we're told, another transit series, but this time it's the shadow going across. And so what I'm just pointing out here are just anomalies, just things that don't reconcile when you start looking into this stuff a little bit deeper. So March 9, 2016, if you download them from the date gallery, so this is where you go and you pick the date and you scroll through the images and download any of them, you find, when you adjust the levels, no noise, no ambient light, and that makes sense. If we go over to the gallery section, it doesn't like this image for some reason. When you go over to the gallery section and download the same image from the same day, just a different section of the website, it has a box around it. So, for whatever reason, 2 different spots, same website, 2 different pages, same day, same image, same event, one has a box, one doesn't. They're changing stuff. They're moving stuff around. That's the whole point here. These aren't just authentic photos that you guys are seeing that we're given. All right, I'm going to switch over to the Lunar Reconnaissance Orbiter real quick. I didn't mention that one when we started off because of the fact that it's not giving us Earth images every day. What we see from these guys is occasionally, this thing was launched, I think, in 2009. It was only supposed to be a 2 or 3 year mission, and it's still allegedly giving us images or photos from the moon now. It's orbiting the moon and studying it. But the LRO occasionally would give us a picture of the Earth. It would just happen to be pointing the right direction or what have you. And so the Earthrise image is what was provided to us in October 12, 2015. Coincidentally, it's only a couple of months after the EPIC camera started giving us images, a few months later. In one of the videos I go through and I show that from the same day that we got the LRO image of the Earth, and you look at the EPIC camera that day, you can basically get the same thing. One taken from 200,000 miles away, one taken from 1,000,000 miles away, but they're framed exactly the same and they match up almost perfectly. So I think they're just using the same image for both satellites. But this is the LRO Earth image, and this was really interesting. The website doesn't even look like this anymore. If you go there now, you use the same address. They've redesigned it all. It's a little bit tougher to find stuff. But this is what I found back in 2017. They gave you this 3 image, allegedly the LRO has 3 cameras, a left one, a right one, and then has 2 cameras, a left and a right one, and then the third image is the composite of the 2. They always got to do composites. They can't just give us they can't just put a camera on a satellite and take a picture and send it to us. It's always got to be something complex. But I dropped, obviously, this set of images into the software, and that's what I found. There's that darn box again. It's always tilted, too. They don't like the Earth straight up and down. It's got to have a little attitude or something. I don't know. It's always tilted. It is. It looks a lot cooler that way. So this was the same event. This was a little bit higher quality image. When you do the same analysis, you see the same thing. No surprise there. Then we had this really high definition one that they included on the website. It was a TIFF file, and I think it was many, many megabytes. But when we performed that image that gamma brightness is what we were using in Photoscape to do this, we turned the levels way up. This is what we saw. I'll give you a second to study that thing. Looks like they attempted to remove the box using like a healing tool brush or something like that in Photoscape. Yeah, it looks like they got halfway done with the job. The guy, heading off to lunch, forgot to come back and finish it or something. I don't know, but that's what we got. What I thought was really interesting then was comparing just the one lower quality image from the LRO with the one that I just showed you side by side. Do you guys see a problem? Is there anything? It's almost like those old magazines, at least when I was young, you'd have two pictures and you had to pick out what are the things that are different, or changed. You guys see it? I'll make it real easy for you. Where'd the mountain go? They cropped the mountain out. I didn't crop it out. I think it was when they did that healing brush, they were removing the box around it. And it might have been a little tough, I think, to do it around the mountain, so they just took the mountain out. Just remove it. Don't need it. He was never existed. Just vanished from the face of the moon. National Artificial Science Association. That's kind of what I started thinking that NASA is, because they're just playing with us. All right, I'm going to switch over real quick. Running out of time real fast. Roscosmos is the Russian space agency. They have a satellite called the Electro-L. And the Electro-L is unlike the Discover satellite, which is always pointed right at the Earth, the sunlit side of Earth, and stays always seeing the sunlit side of Earth. This satellite allegedly just is pointed above the eastern hemisphere, really above Russia, equatorial plane of the Earth, equatorial area. And so you see the Terminator line moving every day, obviously, based on, the heliocentric models. The sun is, the Earth is moving around the sun, so you get these shadows. But what we found is that every day at the same time, it was 2030 was the time, which was local time in Russia, obviously, so it was usually dark. When you increase the levels, you get this line down the middle of these things, of these images. We found that always at the same day at the same time. It was like the software was resetting that time or something like that as they generate these images, because we're getting Electro-L images like every 30 minutes, I believe is the time frame there. And I'm going to skip that one because we don't have time. I'm going to go to JAXA, which is the next one. This is where we started looking into the Japanese Space Agency. And this is allegedly from 2007. We got this video from the JAXA Space Agency. And, I'm no video game designer or anything like that, but I played a lot of video games as a kid, and this looks like a video game to me. Do you guys really think that's the moon? That just looks like a cartoon. It really is a cartoon. We're told by JAXA this is real. So the one I'm going to focus on is the Himawari 8. Many of you guys have maybe heard of this satellite. This one allegedly gives us a picture of the Earth every 10 minutes. And it's really hard to dig through these images because they put them all in one single folder. And so when you go there on your computer, it has to load like all of these images, and they do it by, I think it's by year now. It used to do it by day, and you could just go to that day and you only have those images. But they've changed it over the last 2 years to where you load up just the year, and you have to wait for all of them really to be able to navigate around. So they've made it really difficult to surf through these. But this is over Japan. This satellite stays there, so you'll see the day-lit and the sunlit and the night side of Earth all at the same time, throughout the day, every 10 minutes, and allegedly, again, 22,000 miles away. Coincidentally, no, I can't change slides. There it is. Himawari means sunflower. I thought that was interesting, with the heliocentric model being the worship of the sun. All right, the Himawari is often brought up as proof of a globular Earth. because they give us these animations. They take the 10-minute images that we get and they stitch them together in these animations. And they're getting better at this stuff, guys, because you'll notice that they've got weather patterns here moving. They got clouds moving and things like that. So this is one that we get often as proof of the Earth being round, essentially. So I wanted to start investigating this, and here's basically what I found. There's 2 spots you can pull these images off of that we get from the Himawari every 10 minutes. This is the Japanese site, and but they have all these borders of the continents and countries and stuff over it, so obviously it was already manipulated at some level. So I wanted to get the raw images, and I found them over on the NOAA site. And here they are coming in every 10 minutes. And these appear to not be manipulated in any way because they didn't have that, all those borders and lines drawn out and that sort of thing. The NOAA is in conjunction with all these satellites I found when I was looking into this because they're measuring space weather. Okay, they're looking for these big events from the sun that could affect things, so they call it space weather. So the NOAA, the National Oceanographic, and I can't remember what the NOAA stands for, but it's weather related. That's where we get a lot of our hurricane information. When the hurricanes are hitting our country here, it's always the NOAA that they're talking about. So I started digging into the website on the NOAA and learning about these images, and I found very quickly that it basically says right here on the bottom where I've underlined, it says, all images in the GOES archive are processed in MIC-IDIS using GOES Channel 1, visible, and GOES Channel 4 infrared data. And then it says, the underlying color land image is from the NASA Blue Marble Next Generation data set. They admit it right there. Okay? These aren't photographs. The underlying land image is from the Blue Marble Next Generation data set, which we've covered. And this is what the data set looks like. This is what began that stitching together that image. These are allegedly data that they got, and then they interpret that into pictures for us, and they use that, wrap it around the sphere, just like Robert Simmons said, and that's where we get the blue marble. And then the Himawari is allegedly, at least in my opinion, based on that text file that's in the FTP server, that's what they're using. Putting the weather basically on top of the Blue Marble data set. So I'm going to play a quick clip from the video that I made because I thought I did a good job on it. But this is my theory on how they make the weather seem very accurate and timely. No sound. Let's try that again. Okay, looks like we don't have sound. You guys want to try it or should I keep going? I'm running out of time. Yeah, this is season 2, episode 2 of Faking Space. Go to fakingspace.net and you'll see it. Essentially what I found was, or at least my theory was, they do weather climate simulations up to the year 2095, and you'll see here in the image coming up how they've got the climate or weather simulated years and years in advance, and they use these images so that obviously the continents are blacked out, but that's the weather over the oceans. And then what they do is they take all the Doppler radar feeds from all around the land, because we know Doppler radar can only be taken over land because it's all ground-based radar. And the NOAA supercomputer receives all that and then obviously crunches that out, and they spit it all over the Blue Marble data set, and then every 10 minutes the weather seems to be very accurate. So they've got climate simulation weather over the ocean, and then they've got the Doppler radar over land. And this comes up really quickly when I started looking into the images again, where I always kind of found that there was basically a line between where the simulated weather of the oceans was and what the actual Doppler radar feed would see on the coast. And you would see a lot of times the weather would basically stop right on the coast from the simulated weather, but the Doppler radar feed that day had clear skies, and so the weather, it looks like it would come up right to the coast of like North and South America on the west coast, and the weather just basically stopped. Like the clouds would never come over land. That's because the Doppler radar that day showed a clear day. And then, of course, the noise and ambient light analysis on the images from the Himawari. I didn't cut that out. That's basically what you see. It's these jagged boxes around them. The Chandrayaan, this is the most recent image I believe that we have of the Earth. This is from just a few months ago, the Indian Space Agency attempted to land on the moon. They didn't. We were told that they didn't make it, but we got some pictures of the Earth from space. So these are the most recent ones. But when I was looking at that, here's what I found. You can look right here. This is kind of what I was talking about a minute ago. Look at the weather as it comes up to the Baja of California or the west coast of the United States there. The weather would come up and basically stop right at the coast and doesn't ever go over land. And so I pulled up just a picture in Google Earth of what the Baja of California looked like, and you can see it's basically the same shape. There's no clouds over land. The weather stops right at the border of where the land begins in a lot of these different images. Here's one from the Discover image that I got in June of 2019. So this is one of the last ones we got from the Epic camera because, again, I told you it's offline. They haven't got an image since June of this year, but this is one of the last ones that we received. And look at North and South America here. Look at how the weather just appears to stop on the coastline. So that just, I think, advances my theory at some level that they're simulating weather of the oceans, and they're using Doppler radar feeds, and a lot of times they don't match up. They just don't match up. Of course, noise and ambient light analysis of the Indian Space Agency image, and nothing new there. National Association of Space Anomalies. That's what I call them. All right, speaking of ambient light, what would be the best object to use to look for ambient light in our solar system? Anybody? The sun. You think there's any light coming from the sun? Again, maybe I don't like, or I lack critical thinking skills, but I think this would be the best example of getting ambient light when we look at some of these images of the sun from NASA. These are animations from images they tell us of the sun. It's almost mesmerizing. But if you take the original and you do a noise analysis and ambient light, there's still no ambient light coming from the sun. That blew my mind. All right, we got to hurry here. Here's the other one. So here's my moon photograph again, ambient light, and compare that with the sun. Same software, same tool, same analysis. A picture of the sun from NASA, picture of the moon from me. One is CGI and one is real. I'll let you guys decide. All right, so Discover, LRO, Himawari, Electro-L, all of these images, NASA, obviously, the Indian Space Agency, all of these images also have something in common besides lacking noise and ambient light. There's no metadata. They strip it out. They strip it out. So we don't know anything about, we can't go back and look when it was taken. Obviously, we can't say the camera settings. They just strip all this stuff out. That's because they're not real, guys. They're CGI. All right, so I'm pretty much out of time. I was going to talk about TRAPPIST. I was going to talk about the other planets. We found that NASA basically makes these flat maps, and they wrap around a ball in software. So that's how they came up with the TRAPPIST system. And this is admittedly artist's conception, so no big deal there. But what I found was when I was looking into the TRAPPIST system, these are images of our planets in our solar system. You guys probably have seen these before. They look familiar. I made those. I just took the same flat maps that were in the FTP folder that they had of all of the planets in our solar system. There they are. There's Mercury, there's Venus, there's Mars, there's Jupiter, Saturn, Uranus, Neptune, Pluto, another one. The guy, it was lunchtime. He was like, I'll finish this later. Oh, shoot. It went out like that. Oh, well, they won't notice. There's Pluto. And then I don't have time to go through Jupiter. So real quickly, the NASA, if you combine all of this stuff that I'm talking about today, and then all the stuff that you guys have seen from the ISS, right? The virtual augmented reality, the swimming pool stuff, pictures of the satellites. Just Google satellites, real pictures of satellites. Google that sometime and then try to see if you are seeing anything but cartoons. I think that's what we're dealing with here. NASA is they're just a CGI company. That's what we're being fed. This is all propaganda. So I call it the National Actors in Scuba Agency. So you guys have probably seen this, not flat, we checked. This is a campaign by NASA. You can get stickers, pins, tablet cases, flip-flops, hats, shirts, obviously you name it. This is my response. Not real, we checked. So that's pretty much it. I got a t-shirt. There's only like, I think 3 or 4 left, but that's my response. So anyway, that's it. Well, I'm totally out of time. Thank you guys so much. I had a blast being here, and I appreciate you so much. Good night.
Awesome stuff. Let's hear from Paul on the plane. Awesome stuff.